Welcome to APDesign Digital Tools. This is from a build on the Spaceframe 101. We're going to now apply a custom surface and see if we can't create the space frame from it. So to do that, we're just going to grab and build a surface. You can do this in any kind of way that you would like. I'm just going to grab a surface plane and then use the point on command to kind of warp it a little bit. Maybe rebuild it. Alright, let's just imagine that that is going to be the build. Alright, cool. So I'm going to use the surface component to target that surface, and I'm going to essentially divide that surface up into a grid and then apply the same logic of the space frame into it. So I'm going to need a couple of components. I'm going to need the divide surface component, actually I'm going to grab the surface isotrim component, get rid of that divide, and you'll see that the isotrim needs the surface, which I've already plugged in, and it needs a domain. So under math, you're going to grab this divide domain, two-dimensional, and that's going to provide the domain. So I'm going to basically grab a couple of these sliders. This was the extent. I'm going to use those. And the domain wants a base domain, which is coming from the surface. So plug that in, and you'll see that, and I'll go ahead and hide this geometry. You'll see that now I've created a kind of grid over the top of the surface that I can adjust. Alright. So from the surface, we get a bunch of these kind of untrimmed surfaces, and you might notice that they're organized the same way as our grid was. Turn that to 15, which is where we had it up above the original, and then 5. So we have similar, oh, I take it back, we aren't similarly organized. In fact, we're in one very, very large list. Okay, so that's all of our subsurfaces. Alright, so what we want to do is we want to start to create similar similar pieces of information. Maybe not, they may not be organized in the same way, but essentially I want to break this down so that in the end I'm sending it maybe a series of curves, and I can go through, find the centroid, and then move the point down and collect the lines, or connect the lines. So from a surface, how do I get to a set of curves? Well, somewhat simple. You just go to and create deconstruct brep. The deconstruct brep has 3 outputs. One is the face, so that is every surface, and the next is edges, so that's each of the edges of the surface, so that is actually a set of curves, and then vertices. Again, these are the points at the corners of the surface. So that looks, these edges look very similar to what we're doing up here. So let's go ahead and attempt to connect here and see what we get. Alright, we have a problem, and the problem is that if we look exactly at what we had from this grid, realize we have a rectangle. from here we have a series of segmented lines. So in fact all four of these would equal the boundary of this entire surface. But they're broken up into singular pieces of curves. So I have to either join these or find a different way of doing it. So if I join them, now I get a closed curve. That should be similar to what I was getting from this grid. So I'll plug that in and let's take a look. It looks like it's actually doing what I want. Now the surface is a lot larger, so I'm probably going to have to give it more depth to look right. So something, say, a nose. Let's go ahead and turn off that. And now we have a custom space frame on a custom surface. Now whether it structurally hold up, I have no idea. Alright, so while we're at it though, we may want to look at one thing. You can see that the space frame is a little bit angry. And the reason for that is my original space frame was moving down in Z. But we see that this surface is a little bit wonky, very custom, some strange slopes, some strange torques. And so Z is not kind of the best mode of moving down. That I may want to use the normals, such as we did in the louver exercise. So I may want to look at how I might generate that. There's a couple other things I see, little anomalies, like that one's not connected. So I may want to address that too. I did find an error in my script. At some point I had put the wrong input. So I have to get this back to 0, and all of that came back to life. Okay, so it looks pretty good with the Z, but in fact, if I start to really change the orientation or really get wonky with the with my surface, you'll see that the Z really becomes kind of ineffective as a direction for the space frame structurally. So here we're going to use the same logic that we used in the louver. We're just basically going to take this centroid, and it'd be a good time to kind of throw a group, maybe a different color onto that centroid so that you know where that is and label it. Because more than likely, over and over again, as you're messing with this script, you're going to be coming back to that point. So having it somehow recognized from a distance is a good thing. Alright, so what I'm going to do is I'm going to evaluate the surface given that point. So I'm going to use the two components, one being the surface closest point, and the other being this evaluate surface. So I'm going to plug in the point, plug back to my original surface. That'll give me the UV. I plug the UV, go back to the original surface with the S, and that feeds us a normal value. And that normal value now will, I probably don't need to have this reverse. We'll see. A normal value, I also need an amplitude, so I'll have to plug in the amplitude, feed the normal into the vector, and then I'm going to use shift control to take it off of there and put the amplitude there. And now it does look like I want the reverse. So I'll just reverse the normal. and voila. So now all of these points are being built perpendicular to the surface at that point. So now it's a little bit smarter. Alright, good luck.